Hello, fifth grade. Today we're going to be working on an activity that's going to be kind of like a puzzle, but it also gives you an opportunity to practice multiplying with mixed numbers and with fractions. So you'll need to either print this off of Google Classroom, or if you just want to write the answers on a piece of paper, that would be fine too. And as you view the worksheet on your computer or your device. So we're going to do a couple together, and then I'll let you finish it on your own. So the instructions say to choose which numbers below the multiplication sentence makes the sentence true. Write the numbers in the boxes. So for each problem, there are two shaded boxes that have missing numbers, and your job is to figure out which number goes where. So, for instance, on number 1, you have two choices. You have a 2 and a 5. So, two boxes, two choices, you have to fill it in, okay? But you want it to be a true equation when you do that. So, it's 3 and 2 somethings times so many thirds is going to give you 2 and 4 fifteenths, okay? So, I'm going to go over here to my handy-dandy whiteboard and think about this. So we have 3 and 2 of something times a number of thirds that have to give us 2 and 4 fifteenths. Okay, so that's not written very well. Let me try that again. Okay, so our choices are 2 and 5. Well, you probably know just logically that a 2 is likely not to go here in the denominator, because 2 halves is not how you would not write a number as 3 and 2 halves. You would write it as 4, right? Because 3 and 2 halves is 1, so 3 and 1 give you 4. So probably the 5 is going to go here and the 2 is going to go here. But I'd like to confirm that. And I would like you to take that step of confirming that your answer, even if you use logic to figure it out, to then use math, okay? Because our purpose here is to also practice the skill. All right, so 3 and 2 fifths times 2 thirds. I'm going to turn this into a fraction problem because we already have a fraction. So I could turn this into a fraction. So 3 and 2 fifths, if we want it to be fifths, 3 of them would be 15 fifths, plus 2 more makes 17 fifths, times 2 thirds. And first thing I'm going to do is look for an opportunity to simplify. I don't see any, because if we swap these, 17 thirds, that is simplest form, and 2 fifths would be simplest form. So we're going to have to multiply. 17 times 2 is 34. 3 times 5 is 15. And 15 goes into 34, pretty sure twice, right? 2 15s is 30 with 4 left over. So we did get the correct answers there. Okay, so let's go on to the next one. So number 2 is a pretty clear-cut problem because it's 1 7/8 times 1/4. All you have to do is solve this. And actually, they give you 4 choices here. You're only going to use 2 of them, so you'll actually do the multiplication. So I'm not going to do that one with you. But let's look at number 3. So we have a whole number of 2 with a fractional part of 6 times a fractional part of fourths that have to give us 2 and 1/8. So again, I'm going to work this out on paper. Our choices are 2, 3, and 5. They give us 3 choices for 2 empty spots. So we're going to have to do a little bit more thinking here. 2 and 1/8. And our choices are 2, 3, and 5. Well, let's think about this right away. I know that if we made this a fraction problem, it's going to look like this, correct? And you know what I'm going to do now is I'm going to put the answer, the product, in fraction form, because I know that way it'll tell me what this needs to look like when we get there. So 2 and 1/8 in fraction form would be 2 times 8 is 16, plus 1 is 17/8. That's what we're trying to get to. Okay, now some of you may have noticed that if we were to multiply 6 times 4 right now, we would get 24, right? 8 is a factor of 24, which is really convenient. So what if we turn this into eighths? So, I mean, into 24ths. It's already eighths. But if we made it 24ths, then that might be a clue for us. So I'm going to make this 24ths by tripling the 8. 8 times 3 is 24. 17 times 3 is 51. So we need this to multiply, we need the numerators to multiply to give us 51 because the denominators multiplying gives us 24. So now this becomes a little more interesting. So now we know that we have 2, 3, and 5 to work with to fill in these two spots, and we're trying to get to a product of 51. So, little guess and check, little trial and error. What if we put the 2 here and the 3 here? Let's just see what happens. Well, if we are turning 2 and 2 6 into 6, that would be 2 times 6 is 12 plus 2 is 14 times 3 does not give us 21. But does 14 times 5 give us 21? No, that doesn't work either. So let's try something different. That doesn't go there, and that doesn't go there. Well, I'm going to do something. I'm going to put the 5 there. Because 3 6 would be, again, it might work, but why would you put it as 3 6 and not 1/2? So I'm going to put the 5 in the numerator. So 2 times 6 is 12 plus 5 is 17. Now that's feeling like that might work because we know that we had a 17 here, and what did we do to it to get it to 51? We multiplied it by 3. So it looks like we've got this right. Now, if we had not done this, if we had not converted the eighths to 24ths, what would we normally do in this case? Well, we would swap and simplify, right? I'm going to swap the denominators, put the 4 here and the 6 here, and then this simplifies to 1/2. 17 times 1 is 17, and 4 times 2 is 8. So we ended up with the 17/8, which is the same as 2 1/8. So these are kind of fun little puzzles. I hope you enjoy them, and feel free to work together, call each other up, collaborate, because you guys do a great job of that, and I would love to see what you come up with. I'll talk to you later. Bye.